This week we've been looking at the bivariate regression model, and in this video I'm going to concentrate on the material from lecture 4 in which we introduced the bivariate regression model and we developed estimators of the intercepts and the slope coefficients. We also went on to show that under the Gauss-Markov assumptions the slope coefficient is unbiased. This week we've been looking at the least squares regression model. In the first stage we've been developing the estimates of the intercept and slope parameters, and we obtain these by taking the residual sum of squares function and then finding the first order conditions for a minimum of the residual sum of squares. So we differentiate with respect to alpha hat and beta hat, and then we use these first order conditions to solve for the unknown parameters. In the first stage we show that we can obtain what we call the least squares normal equations from these first order conditions. This is essentially a pair of simultaneous equations in alpha hat and beta hat which we can solve for our estimates. Least squares normal equations lead to some quite interesting results. First of all, if we take the first of the least squares normal equations here, we see that dividing through by n, the number of observations, we can show that the regression line must pass through the sample means of the data. So we have y bar equals alpha hat plus beta hat x bar. Now we can go on to use that to develop our estimator of the slope coefficient. First of all, if we solve for alpha hat, we have alpha hat equals y bar minus beta hat x bar, and then we substitute that into the second of the least squares normal equations here. And this gives us the equation here. Now if we group together the terms in beta hat on the left hand side and the other terms on the right hand side, then we obtain this equation here. Beta hat into sum of xi squared minus nx bar squared equals sum of xy minus n x bar y bar. But we can write that in a more convenient form. First of all, we note that the sum of xi squared minus n x bar squared equals the sum of xi minus x bar all squared. This is a very easy thing to demonstrate using algebra, so I'll leave that as an exercise. Secondly, we can show that the sum of xi yi minus n x bar y bar equals the sum of xi minus x bar yi minus y bar. Again, this is left as an exercise. So we can write our expression for beta hat in the form given here. We have beta hat multiplied by the sum of xi minus x bar squared equals the sum of xi minus x bar yi minus y bar. And if we divide both sides by sum of xi minus x bar squared, we have the expression that we use for beta hat. But there's one other interesting feature of this.